Alright guys, for 2.5, solving equations involving absolute values. The big idea, the thing that I want to stress to you guys right off the bat with this is that an absolute value is essentially just a distance. Okay, and if we're talking about distances, no matter which direction you come from, typically if we're talking about a distance, we're talking about it in a positive sense. Basically, if I say the distance from my house to PUC Prep is 10 miles, that distance that I talk about is always positive. I don't ever say it's negative 10 miles or something like that, right? So distance is always positive. So we think of absolute value as a distance. Typically it's a distance from 0, but we can modify that and obviously make it a distance from any number. All right, so when we're talking about absolute values, we're talking about a distance from something. All right, so it's going to be a positive answer whenever we take the absolute value. So if you have an absolute value bar, we will always set that to equal a positive number. Okay, but that said, okay, what I want you to think about right off the bat before we get into anything is this idea. Say that I'm at 0. Okay, say that I'm right here at 0 on a number line. Okay, if I told you to move 12 feet or 12 units or 12 spaces from 0 on a number line, you have two options, don't you? You could move 12 in this direction, and on a number line you would be at positive 12. Or you could move 12 spaces in this direction, and you'd be at negative 12. No matter what you did, the distance from here to here is positive 12, right? And the distance from here to here is also positive 12. But you have to, with absolute values, when you're solving them, when you have a variable, you have to consider the fact that you could be working from a negative direction, okay? So we could still set absolute values to equal it. Well, we can't set an absolute value to equal a negative, but we can set, when we take something out of absolute values, we can set that to equal a negative because we can look at things from a negative distance. Or a negative direction, if you would, not a distance. Okay, so when you're thinking of absolute values today, always think of this as a distance. It is always positive. Okay, always positive. So example 1 says evaluate the expression if x equals 2. All right, so here we have these absolute value bars. This means a distance. So saying 23 minus some distance. All right, so this is an expression. I want to highlight this. This is an expression. There's no equal sign. Okay, there's no equal sign here. And we're saying x is equal to 2. So let's just plug it in. So we have 23 minus absolute value of 3 minus 4 times 2. If I do that out, I get 23 minus the absolute value of 3 minus 8. 3 minus 8 is equal to 5, negative 5. So I get 23 minus, notice how I'm not doing anything on, I'm not turning anything positive here or doing anything with the absolute values until this is simplified. Here it becomes simplified, right? So now I only have one number in here, right? So that's simplified. So I have 23 minus the absolute value of negative 5. The absolute value of anything is always a positive number. So I have 23 minus 5, which is equal to 18. All right, so I took the absolute value at the very last step. You can almost treat that absolute value, the absolute value bar is like a parentheses or something like that. So that is how we would do an expression. Now, when we get into equations, the key concept is this. So whenever there's an equal sign, right? Equal sign, think equal sign. There are two cases to consider when you're solving an absolute value equation. The positive and the negative. And then I wrote here to note, absolutes are always equal to a positive, but variables inside of absolutes could be negative, so we must consider them. What that means is we must consider things that happen in the negative direction, right? So again, if we're on a number line, you guys, and we're here, let's just say we're here at 3, right? If I'm here at 3, okay, and I said I need to go a distance of 5, I can go in this direction and be at 8, or I can go this direction and I can be at negative 2. Both of them give me a positive 5 distance from 3. Okay, that's important to recognize. So whenever there's an equal sign with a variable that is inside of the absolute values, I have to consider the fact that it could be from the positive direction, okay, like this, or it could be from the negative direction, like so. So whenever you have an equation with an absolute value equal to some number with a variable on the inside, you have to set it to equal both the positive and the negative. Okay, so notice what I did was I took this out of the absolute value sign. Okay, I took f plus 5 out of the absolute value signs. So there's no more absolute values. In this step here, you guys, in the blue here, change this to blue. In the blue box here, there's no absolute values anymore. So I took the f plus 5 out of absolute values, and I set it to equal positive 17, and I set it to equal negative 17. All right, so once I've done that, now I can solve both of these to figure out what f is, the possibilities for f. So I could say, okay, f plus 5 is equal to 17. And then I could also say that f plus 5 is equal to negative 17. And then I could solve both of these. So I want to get this guy by itself. I'm going to subtract 5. Subtract 5. If I do that, I get f is equal to, that's an equal, not an f. F is equal to 12. And then here, if I subtract 5 from both sides, I get f is equal to 22. Okay? And if you're wondering what number, sorry, and this is not just 22, it's negative 22, right? So if you're wondering what number that this is referring to, like what the middle number is between these, what you can do is, we're looking at a distance of 17 here, right? This is a distance equal to 17. So I can look at 17 from both directions. If I subtract 17 from 12, I'm at negative 5, right? And if I take negative 5 and subtract 17, I'm at negative 22. So negative 5 is the central number. Okay, so 17, if you're on a number line, what I want to show you guys is this. If you're on a number line, here's 0, here's negative 5. What we're saying is, okay, we were at negative 5, and an easy way to get that is to see that whatever makes the absolute value go to 0, okay, and if you don't understand this right now, don't worry about it. But notice if I plug a negative 5 in for f, negative 5 plus 5 here in these absolute values equals 0, right? So whatever makes this go to 0 is always going to be the thing that we are talking about, like where we're making a distance. So the distance from negative 5 is 17. Okay, so I can go 17 in this direction, and if I do that, I end up at 12, right, which is one of my answers. And if I go 17 in this direction, I end up at negative 22, which is my other answer. So 12 and 22, negative 22, are my two answers to the absolute value of f plus 5 equals 17, because I have to consider both things. This is a distance of 17, this is a distance of positive 17, but one of my answers is negative because it's in the negative direction. All right, so I want to make that very clear. So example 2 says solve the equation, then graph the solution. Okay, so we have some distance is equal to 4, right? So always think of this as distance. Distance is equal to 4. So what I can do is I can say, okay, y plus 2 is equal to 4. But then I also have to consider the negative direction possibility. So I can say y plus 2 is equal to negative 4. And then solve both of these. So I would subtract 2 from both sides. Y is equal to 2. And then if I subtract 2 from both sides here, I get y is equal to negative 6. Okay, the distance we're talking about is 4. Technically, in this case, it's whatever makes this go to 0. So negative 2. So negative 2 is where we were originally, and the distance was 4. So if I go 4 in this direction, I'm at 2. Boom, that's that answer. If I go 4 in this direction for negative 2, I'm at negative 6. Boom, that answer. So those are my two solutions, 2 and negative 6, which are 4 away from negative 2. All right, so here we go. For 2b, think about this. Can an absolute value ever equal a negative number? Can you ever have a distance that is negative? And the answer to that is, well, technically yes, if we're talking about a negative as being a direction. But in math, we're not talking about vectors, we're just talking about numbers. So we can't have this negative distance. So since we are not talking about direction here, whenever you have a distance that is equal to a negative, okay, now notice up here, I set this to equal a negative here, but there's no distance anymore because I dropped the absolute value sign. So there's no more absolute value signs when I did this, right? Here, we still have the absolute value signs, and it's equal to a negative. Whenever you have an absolute value equal to a negative, you know that it's no solution, because a distance can never be negative. I will put one of these on the test. It is the easiest problem on the test, but it is also the most missed problem on the test. And the reason for that is people simply forget that a distance cannot equal a negative, and they try to solve this. All right, so if you try to solve that, you'll get an answer, but the answer will be incorrect because there's no solution. There's never a distance that equals a negative. All right, so make sure you get that in your notes. For example 3, we have a word problem that says ice cream should be stored at 5 degrees with an allowance for 5 degrees. Write and solve an equation to find the max and the min temperatures at which ice cream should be stored. Use a number line to solve. Okay, so what this is saying is we should have ice cream stored at 5, right? But we could add 5 to that, or we could subtract 5 to that. So 5 plus or minus 5. So real quick, before I find my equation, I know the kind of the flexibility of ice cream, right? I can take 5 and I can add 5 and I'd be at 10. And I can take 5 and subtract 5 and I'd be at 0. So those are my two solutions, right? I can be at 10 degrees or I can be at 0 degrees or anything in between. But what this is saying is write and solve an equation, so an absolute value equation, to find the maximum and minimum temperatures at which ice cream should be stored. So we already found the maximum and the minimum without doing anything. Like we didn't find the equation or anything like that, which is okay. But let's see if we can figure out how we can make an absolute value equation. So could we say that, so basically, what I want you to think about with this is, we know that the distance is the same as the allowance, right? We can have plus or minus 5 degrees. That's a distance, right? So I could say the absolute value of something is equal to 5, right? We have a variance of 5 degrees. We have a difference of 5 degrees, or a distance of 5 degrees from some central location. That central location in this case is 5 degrees. Okay, so what I've been stressing is whatever makes this thing go to 0, right? Whatever makes that go to 0 is where my central point is. So if we're at positive 5 there, we can just say x minus 5, absolute value is equal to 5. And then I want to test to make sure that this actually works. Okay, so this is saying some distance from 5 is equal to 5, which I think is what we're trying to do here, but let's make sure. So if I just solve this, I could say x minus 5 is equal to 5, and I can say x minus 5 is equal to negative 5, set it to equal to negative. If you solve these, you add 5 to both sides here, we get x is equal to 10, which was one of ours, right? And then if we add 5 to both sides here, we get x is equal to 0, which is my other one. So now I'm confident that this is the equation, the absolute value equation, for ice cream with a 5 degree variance. All right, that is the word problem for example 3. Now, let's come up with, so we only have a couple more slides here, guys, so bear with me. It says writing an absolute value equation. Okay, so if they give you a graph, you can find the equation. How you find it is 3 steps. First, we're going to find the midpoint between the 2 points. So we're going to add the 2 points together, and we're going to divide by 2. The midpoint tells us something about it tells us something about our distance, right? So the distance from the midpoint to either of our endpoints is what the absolute value is equal to. For step 2, we find the distance to the midpoint. Okay, so maybe we find that that's 10. So then we would know the distance is equal to 10, right? And then step 3 is write the equation, which is x minus the midpoint is equal, in absolute values, is equal to the distance to the midpoint, and that is always a positive number. All right, so let's try one of these. So here's an example. It says 4 plus negative 2 in parentheses is divided by 2. The reason that we're doing this math is we are looking at this picture. So if we look at this picture, we're trying to find the midpoint between 4 and negative 2. How we do that is we add them together. So 4 plus negative 2, which is 2, that equals 2. And then we're going to divide that by 2. That will always give me the midpoint. So the midpoint is 1. Now, if you don't know that, that's okay. You can actually also count, right? So if this is my shaded line that's here, I can count and say, okay, there's 1, 2, 3, 4, 5, 6 spaces here. So I'm going to go 1, 2, 3, and mark the space after the third, which is 1. So 1 must be the middle. Midpoint's just another name for the middle. So we can find the middle. Okay. The algebraic way of finding it, or the mathematical way of finding it, is taking the two pieces, the two endpoints, adding them together and dividing by 2, which is what I did here. Okay, so now what we have to do for step 2 is we got to find what the distance is. So this is our middle number. Absolute value is always talking about a distance from the middle number. Okay, so what distance do I go to get to here and here? It should always be the same. In this case, it is 3. Okay, so my equation, my absolute value equation, will always be an absolute value of some variable. Okay, so this, it's whatever makes this go to 0, right? So if I said x minus 1, if I plug this 1 in, it would make that go to 0, right? So if I had a negative 1 as my middle number, then it would be x plus 1. All right, so it's whatever makes it go to 0. Okay, and this is equal to the distance, which is 3 in this case. Okay, and the solutions are given, right? They give us the solutions. The solutions are negative 2 and 4. Those are both a distance of 3 away from 1. Right, so they're going to have you go backwards. So here, for example 4, it says write an equation involving absolute value for the graph. And then it says 1727. So let me see if I can figure that out. So what I think this means is if there's a point at 17 and a point at 27, give me an absolute value equation for that. Okay, so what we have to do is we have to find the midpoint. So to find the midpoint, we're going to take 27 plus 17 divided by 2. If I add those two together, I think it's 44, right? So it's 30 plus 14, which is 44, divided by 2, which is 22. So 22 is the middle number, which looks good, right? That looks like the middle. Okay, so now what I do to finish this is I say, okay, if 22 is the middle, I'm going to take some variable, we'll call it x, and then we'll subtract 22, because if you plug positive 22 in for this x, then I would get 0, right? So the absolute value of x minus 22 is equal to, okay, and then what is the distance from 22 to 27 and 22 to 17? The distance is 5, okay? So there's your equation, right? When you have points at 17 and 27, the absolute value of the x minus the middle guy is equal to 5, because the distance in either direction from 22 is equal to 5. Now I know that this is a little bit probably still confusing, so we will do more of this in class and we'll work some examples together, but here's the introduction at least to absolute values. We'll see you guys next time.